Hello everyone, welcome to Create a Civil Engineering Coach. In this video, I'll be discussing about PGCET 2020 Civil Engineering question paper. So let's begin with the part 1 questions. Question number 1. The unit of elastic modulus is same for those. Unit of elastic modulus is Newton per meter square. So this unit is same for stress, shear modulus and pressure. So option A is the right answer. Question number 2. Which of the following represents biaxial state of stress at a point? So in a state of biaxial stress, strain has two components, one caused by stress along its direction and another caused by its stress along perpendicular direction. So the right answer is option D. Here you can observe in this figure, there are stress caused by its direction and the other stress is caused by perpendicular direction. Question number 3. For the beam shown in the figure, support reactions RA and RB respectively are. So we have to find the reaction at point A and reaction at point B. Total length of the given beam is 2 meter plus 2 meter plus 4 meter plus 2 meter plus 2 meter. It is 12 meter. So reaction from point A is RA into total length of the beam 12 meter is equal to 100 Newton into 2 meter plus 100 Newton into 10 meter. So RA is equal to 1200 Newton divided by 12 meter, which is equal to 100 Newton acting downwards. Similarly, from the point B, RB into total length of the beam 12 meter, 100 Newton into 2 meter plus 100 Newton into 10 meter. So RB will be 1200 Newton divided by 12 meter. So reaction at point B will be 100 Newton acting downwards. So the correct answer is option C. Question number 4. The maximum negative bending moment in case of fixed beam carrying UDL is at. So let us consider a fixed beam subjected to a UDL load of intensity W kilonewton meter for a span length of L. This is corresponding bending moment diagram, where you can observe there are negative bending moment at either of the support and positive bending moment at middle of the span of beam. So there are 2 points of counterflexure where the bending moment is changing from positive to negative, acting at a distance of L by 2 root 3 from either of the support. So the maximum negative bending moment in case of fixed beam will be at either of the support. This will be the maximum bending moment. So option D is the right answer. Question number 5. For the beam system shown, if the slope at M is 0, then the ratio of T by S is equal to. Slope at M, S L square divided by 2EI. Slope at M due to load T is equal to T into 2L square divided by 2EI, which is equal to T into 4L square divided by 2EI. So 2TL square divided by EI. For the slope at M to be 0, S L square divided by 2EI is equal to 2TL square divided by EI. EI will be cancelled, L square will be cancelled. So S by 2 is equal to 2T. Therefore T by S is equal to 1 by 4. So option C is the right answer, 1 by 4. Question number 6. Mass curve of a rainfall shows the variation of. In the following figure, you can observe the mass curve which represents the cumulative rainfall versus time. Option A is the right answer. Question number 7. The terms of saturation vapor pressure PS corresponding to the water surface temperature and the actual vapor pressure in A, PA. The Dalton law of evaporation can be stated as. According to Dalton law, rate of evaporation is proportional to the difference between the saturation vapor pressure at water temperature and the actual vapor pressure at air. So it is represented by the formula E is equal to K into saturation vapor pressure minus actual vapor pressure. So the right answer is option C. Question number 8. Muskingum method of a flood routing is a hydrological channel routing method. Option C is the right answer. Question number 9. A hyetograph is a graphical representation of rainfall intensity and time. Option A is the right answer. In the following figure, you can observe hyetograph graphical representation. Question number 10. The value of sodium absorption ratio for high sodium water lies between. In the following table, you can observe the sodium absorption ratio and the corresponding water to be denoted. So, high sodium water content lies between the range of sodium absorption ratio of 18 to 26. Option C is the right answer. Number 11. Consider the following statement in the context of curves. The correct statements are: statement number 1. Simple circular arc is used for horizontal curve. This is true statement because for horizontal curve, the simple circular arc is used. Statement number 2. Square parabola is generally used for summit curves with the design criteria as sight distance. This statement is also true because for the summit curves, square parabola is generally used. Statement number 3. Spiral is used for valley curves with the design criteria as comfort. So, this statement is false because spiral curves are used for transition curves and not for valley curves. It is used for transition curves. So, out of these given statements, the correct statements are statement 1 and statement 2. So, the right answer is option A, 1 and 2. Question number 12. While conducting a plate load test over a 30 cm diameter mild steel plate, the pressure at 0.6 MPa for a deflection of 1 mm, the modulus of soil is. The modulus of soil is calculated by the formula 1.18 into P into A divided by delta, where P is the pressure, that is 0.6 MPa. A is the diameter of the mild steel plate, that is 30 cm, which is equal to 300 mm. Delta is the deflection 1 mm. On substituting this value, the modulus of soil will be 212.4 MPa. So the correct answer is option A. Question number 13. Coning of wheels. Coning means it is an inward provision of slope 1:20 provided on wheels to counteract the centrifugal force acting on the train. So it prevents a lateral movement of wheels, provides a smooth running of the trains, and avoids excessive wear of the inner faces of rail. So all these statements are correct. So the right answer is option D, all of the above. Question number 14. Arrangement made to divert the trains from one track to another is known as. So when the arrangements are made to turn out the rail from one track to another, it is called turnout. Option C is the right answer. It is provided on the railway track to provide facilities for diverting the train from one track to another. Question number 15. Pick up the incorrect statement from the following. Statement A. As a wave of sea water approaches coastline, it is generally accompanied by the drift of water in the direction of wave distance. This statement is true. Statement B. The onshore wind helps to produce wave action as well as rise of mean sea level. Statement B is also true. Statement C. A falling hydraulic gradient occurs in direction of the wave. This statement is false because a hydraulic gradient line may fall on the rise depending on the change in pressure. So, it does not occur in the direction of waves. It occurs in change in pressure. Statement D. The wave while receding carries finer particles out of deeper water. This statement is also true. Out of these given statements, the incorrect statement is option C. A falling hydraulic gradient occurs in direction of the wave. Question number 16. Which among the following method of forecasting is more suitable for old and settled Indian town? Among this population forecasting method, the best method for old and settled Indian town with a considerable development is arithmetic increase method. Option A is the right answer, because in this method it is assumed that population is increasing at the constant rate. So the right answer will be option A. Question number 17. Which among the following disease is not a waterborne diseases? Waterborne diseases are caused by microorganisms in untreated or contaminated water. So among these options, jaundice, typhoid, polio, all these are waterborne diseases, but influenza is a viral disease. So the correct answer is option D, influenza. Question number 18. A grid chamber treating 3000 liters per second of wastewater with a flow through velocity of 0.3 meter per second, then the cross section area of the grid chamber will be. So we know that discharge is equal to area into velocity. So area of the grid chamber will be discharge by velocity. So area will be 10 meters square. Option B is the right answer. Question number 19. Biochemical oxygen demand BOD of a safe drinking water must be. For a safe drinking water, BOD content should be nil. Option D is the right answer, because BOD represents the amount of biodegradable organic matter present in water which is to be treated for purifying. So for drinking water it should be nil. Question number 20. By boiling water, hardness can be removed if it is due to. When the hardness is caused due to the bicarbonates of calcium and magnesium, it can be removed by boiling. Option B is the right answer, bicarbonates of calcium. Liquid limit and plastic limit of a soil finer than 2 micrometer with a percentage fraction of 25% as 55% and 30% respectively. So activity ratio of the soil will be. We know that activity ratio is the ratio of plasticity index of a soil divided by percentage of the particles finer than 2 microns. So plasticity index is the difference between liquid limit minus plastic limit. So the percentage of fraction of particles is 25%. Liquid limit is given as 55%. Plastic limit is 30% divided by 25% of particles which is finer than 2 microns. So activity ratio will be 25 divided by 25, which is equal to 1. So activity ratio will be 1. Option B is the right answer. Question number 22. Consider the following statements. Statement 1. Increasing volume of the soil without disturbance on submergence in water is termed as free swell of soil. So this is true statement. Statement number 2. Clay soil rich in montmorillonite exhibits very low swelling characteristics. So if the clay mineral is montmorillonite, it exhibits very high swelling characteristics. So it is a property of high swelling. So it is a false statement. Statement 3. Reduction in volume stops when the water content falls below shrinkage limit. So there will be a reduction in volume when the water content falls below the shrinkage limit. So this is true statement. Out of these given statements, the correct statements are statement 1 and 3. So the right answer is option B, 1 and 3 only. Question number 23. 2 points on the virgin compression curve for normally consolidated soil are. These are the void ratio at 2 different points. At point 1, void ratio is 1. At point 2, void ratio is 0.7. And these are the corresponding normal stresses. Compression index will be 0.6287, which is nearly equal to 0.63. So the correct answer is option B. Question number 24. The minimum water content at which the soil just begins to crumble when rolled into threads of 3 mm in diameter is known as plastic limit. Option D is the right answer. Question number 25. Failure of the stability of slopes generally occurs along. So failure of the stability of slopes generally occurs along a curved surface. Option A is the right answer. Question number 26. Geological cycle for the formation of soil is. The formation of the soil in a geological process will be weathering, transportation, deposition and upheaval. So in the following figure you can observe the geological process for the formation of soil. Question number 27. In a statically indeterminate structure, sum of rotation factors of all the members meeting at one joint will be. So rotation factors which are computed for all the members at each joint should be Uij is equal to minus 0.5 into Kij divided by summation of Kij. So the sum of rotational factors at joint will be minus 1 by 2. So option B is the right answer. Question number 28. For the static indeterminacy of the plane frame shown in the figure, we know that static indeterminacy is the sum of external static indeterminacy plus internal static indeterminacy minus force releases. External static indeterminacy means it is number of reactions minus 3. Internal static indeterminacy means 3 into C, where C is the number of the closed loops or closed box minus force releases. Number of reaction components is, for fixed support it is 3, for roller support it is 1, for fixed support 3, for hinge support it is 2. So there are 3 internal rollers, so it is 1 plus 1 plus 1. So the number of reactions is 12. So there are 2 closed loops, so C is equal to 2. Number of force releases will be, for this internal support it will be 1, that is shear force. For this internal roller the number of force releases is 2. One is axial force and another one is bending moment. For this type of the internal roller the number of force releases is 1, that is axial force. And for this internal hinges the number of force releases is m minus 1. M is the number of members meeting at the point, so the total number of members meeting at the point is 4, so 4 minus 1. Therefore force releases will be 7. On substituting these values, the degree of static indeterminacy will be R is 12, 12 minus 3, 3C, 3 into 2 minus force release. Force release is 7. On solving this, the degree of static indeterminacy of the given plane frame will be 8. So the right answer is option A. For a 3-inch parabolic arch, what will be the ratio of L by R to satisfy H is equal to W? In a 3-inch parabolic arch, there are 3 hinges as the name itself suggests. 2 hinges will be at either of the support and 1 hinges will be at crown. So reaction at point A is equal to reaction at point B is equal to load by 2. So considering the moments at the crown is equal to 0, RA into L by 2 is equal to horizontal thrust from point A into central rise. So RA is equal to W by 2 multiplied by L by 2 is equal to HA into R. So WL by 4 is equal to HA into R. If HA is equal to H, which is equal to W, therefore WL by 4 will be W into R. So W will be cancelled. So L by 4 is equal to R. So in the question it is asked to find the ratio of L by R. So L by R is equal to 4. So the right answer is option D. Question number 30. Castigliono's first theorem is applicable for. Castigliono's first theorem is applicable for linear or non-linear elastic structure in which the temperature is constant and the support are unyielding, which means that only when the principle of superposition is valid. Option C is the right answer. Question number 31. The degree of static indeterminacy up to which column analogy method can be used is. So the degree of static indeterminacy in the column analogy method is maximum of 3. So it can be applicable for maximum of 3 degree of indeterminacy with a variable moment of inertia of members. Option B is the right answer. Question number 32. While using 3 moment equation, a fixed end of continuous beam is replaced by additional span of 0 length. Option A is the right answer. According to theorem of Clapeyron's, we use the following assumption. First assumption is imaginary length of a beam. Second assumption is infinite stiffness of the beam. And third assumption is replacing the fixed end with simply supported end. So these are the assumptions according to the theorem of Clapeyron's. Question number 33. A vertical wall is subjected to a pressure due to one kind of liquid on one of its sides. The total pressure on the wall acts at a distance of from the liquid surface. So let us consider a vertical wall of a height h. This is the corresponding pressure distribution diagram. So pressure at top will be 0. Pressure at bottom will be rho g h. Resultant pressure will be rho g h square divided by 2. So the total pressure on the wall acts at a distance of 2h by 3 distance from the liquid surface. Option C is the right answer. Question number 34. The total energy line lies over the hydraulic gradient line by an amount equal to velocity head. Option C is the right answer. Question number 35. Choose the wrong statement. Option A. Viscosity of the fluid is the property which determines the amount of its resistance to a shearing force. This is a true statement. Option B. Viscosity is expressed as Poise, Stokes or Seabolt seconds. This is a false statement because viscosity is expressed in Newton second per meter square. Option C. Viscosity of the liquid decreases with increase in temperature. Viscosity of the liquid is appreciably affected by change in pressure. So this is a true statement. Option D. Viscosity is due to primarily to interaction between fluid molecules. This statement is also true statement. Out of these given statements, the false statement and the wrong statement is option B. So option B is the right answer. Question number 36. Field capacity is 40%, permanent wilting point is 12%, readily available moisture is 60% of available moisture. What is the optimum moisture content? So let us draw different zones of moisture content. So there are 3 zones. This is permanent wilting point zone. This is optimum moisture content. This is field capacity. So this zone will be 0.6 times of field capacity minus permanent wilting point, and this zone will be 0.4 times of field capacity minus permanent wilting point. So in order to determine optimum moisture content, it is 0.4 times of field capacity minus permanent wilting point plus permanent wilting point percentage. So 0.4 into field capacity is 40%, permanent wilting point is 12%. So optimum moisture content will be 23.2%. Option C is the right answer. Question number 37. Which one of the following methods of applying water may be used for rolling lands? So for the rolling lands, the best method of applying water is free flooding. Option D is the right answer. In the following figure, you can observe the method of applying water for rolling lands, where in this technique it is suitable for sloping land and crops like pastures. In this method, contour ditches called subsidiary ditches are made and are generally spaced about 20 to 50 meters apart. And in this method, the water application efficiency is very low. Question number 38. A regime channel carries a silt of medium size of 0.25 mm. Lace's silt factor for this silt is. According to Lace's theory, the silt factor is given by the formula F is equal to, where D is the size of the silt. So, silt factor will be 1.76 times of square root of 0.25, which is equal to 0.88. So, the right answer is option B, 0.88. Question number 39. The bottom portion of the concrete dam is usually stopped in order to. So, the bottom portion of the concrete dam is usually stopped in order to increase the shear strength of base of the dam. Option B is the right answer. Question number 40. The maximum irrigation requirement of rice crop is exhibited by. In the following table, you can observe the duty and delta values of different types of the crops. So, from the table we can say that water requirement or delta of the rice crop is maximum and duty of the rice is minimum. So, both these properties are inversely proportional to each other. So, the maximum irrigation requirement of rice crop is exhibited by its minimum duty value. Option C is the right answer. Question number 41. Which will be the included angle of POG if the bearings of the line OP and OG are 320 degree and 20 degree respectively? So, let us draw an included angle between POG. So, bearing of P and O is 320 degree and bearing of OG is 20 degree. So, the included angle is 360 degree minus 320 degree plus 20 degree. This is the bearing from PO and this is the bearing from OG. So, it is 60 degree. The included angle is option A, 60 degree. Question number 42. If the points are inaccessible, which method of the plane table survey is adopted to plot the points? So, when the points are inaccessible, the best method in the plane table surveying would be intersection method. Option B is the right answer. Intersections are the group of planar surveying calculations where we use two control points with a known coordinates and certain angle or distance measurements to compute the coordinates of unknown points. So, the right answer is option B, intersection method. Question number 43. If the lower dam screw is tightened and the upper clamp screw is loosened, the theodolite may be rotated. So, the theodolite may be rotated with a relative motion between the vernier and the graduated scale of lower plate. Option A is the right answer. Question number 44. To observe an included angle with better accuracy, then what is achieved by reading the vernier of a theodolite? The method preferred is. To observe an included angle with a better accuracy, the best method would be repetition method. Option A is the right answer. In this method, the same angle is added several times mechanically and the corrected value of the angle is obtained by dividing the accumulated reading by number of repetitions. So, the correct answer is option A, repetition method. Question number 45. The temporary adjustments which are done before observation at every setup of theodolite consist of. Statement 1. Setting up a theodolite over the station. This is a temporary adjustment. Leveling up is a temporary adjustment. Elimination of parallax is a temporary adjustment. So, these adjustments are done before setting up the theodolite. Orientation is the permanent adjustment after setting up a theodolite. So, among these four statements, the correct temporary adjustments would be statement 1, 2 and 3. So, the right answer is option B, 1, 2, 3. Question number 46. Which of the following bonds in masonry is most aesthetically pleasing bond? The most aesthetically pleasing bond is Flemish bond. Option D is the right answer. In Flemish bond, you can observe in the following picture. It consists of headers and stretchers alternately so laid so as to break joints. So, it is the most aesthetically pleasing bond. Question number 47. Which of the below roof types can be used for a span of 3.5 meter? For a span of 3.5 meter, it would be a couple roof. Option C is the right answer. So, if the span of the roof will be 2.5 meter lean to roof will be considered. And suppose if the span of the roof is 4.6 meter, collar beam roof will be adopted. So for a 3.5 meter, it is a couple roof. Option C is the right answer. Question number 48. A good building stone should not absorb water more than. So for a good building stone, the water absorption should be less than 5%. Option A is the right answer. Question number 49. Percentage of the carbon content in mild steel is. The carbon content percentage in a mild steel would be less than 0.25%. So option A is the right answer, less than 0.25. Question number 50. The triangular space formed between the extrados and horizontal line drawn through the crown of an arch is known as. In the following figure, you can observe the triangular space formed between the extrados and the horizontal line of the crown of arch. So this space is called as spandrels. Option C is the right answer, spandrel. So this completes part 1 questions of this question paper. Now let's begin with the part 2 questions. Question number 51. A column has a slenderness ratio of 65. Young's modulus and crushing strength of the column are 200 GPa and 330 MPa respectively. According to Euler's theory, column would preferably fail through. We know that according to Euler's theory, it is valid only when the slenderness ratio is greater than or equal to critical slenderness ratio. So from Euler's theory, the Euler's critical load of a column is equal to pi square EI by L square. So this formula is applicable only when the crushing strength is greater than or equal to buckling stress. Therefore, crushing strength of the column should be greater than or equal to pi square E divided by critical slenderness ratio, which means that critical slenderness ratio is equal to pi square E divided by crushing strength of the column. So critical slenderness ratio is equal to pi square into E is the Young's modulus, which is given as 200 GPa, so 200 into 10 to the power of 6 divided by crushing strength, which is given as 330 MPa, so 330 into 10 to the power of 3. On solving this, the critical slenderness ratio is equal to 5981.57. Therefore, critical slenderness ratio is equal to 77.34. In the given question, the column slenderness ratio is 65 and the critical slenderness ratio is 77.34, which means that the given slenderness ratio is less than critical slenderness ratio. So according to Euler's theory, if the given value of the slenderness ratio is less than the critical slenderness ratio, then the column would fail through crushing parameter. So option A is the right answer. Question number 52. A closed pressure vessel with the plate thickness of 10 mm, internal diameter of 240 mm is subjected to an internal pressure of 5 MPa. What is the shear stress of an element of a cylinder wall on a plane at 30 degree to the longitudinal axis of the cylinder shown in the figure below? So thickness is given as 10 mm, internal dia is given as 240 mm and pressure is given as 5 MPa. We know that hoop stress is given by PD by 2T. P is the pressure intensity 5 MPa, D is the diameter of the cylinder 240 mm, T is the thickness of the cylinder. So hoop stress will be 60 Newton per mm square. Similarly, longitudinal stress will be PD by 4T. So 5 into 240 divided by 2 into 10. So longitudinal stress will be 30 Newton per mm square. So the shear stress will be hoop stress minus longitudinal stress divided by 2 into sin 30 degree. Shear stress will be 12.99 Newton per mm square. So the right answer is option D, 12.9 Newton per mm square. Question number 53. A 12-hour storm of x centimeter at a particular place has a return period of 50 years. The probability of a 12-hour rainfall of x centimeter or larger magnitude will occur at least once in 10 successive years in percentage will be. So probability is equal to 1 by return period. So 1 by 50, which is equal to 0.02. Q is the probability of a rainfall not occurring in a given period. So for not occurring, 1 minus P, so 1 minus 0.02, therefore it is 0.98. 1 minus Q to the power of N. So 1 minus 0.98, N is the successive number of years, so 10. So probability of rainfall occurring at least in n successive years will be 18.3%. Option C is the right answer. Question number 54. A direct runoff hydrograph due to a 4-hour storm in a drainage basin is triangular in shape with a base of 84 hours and the peak discharge of 90 m3 per second. Drainage basin is about 400 km square. The peak of 4-hour unit hydrograph for this basin in meter cube per second will be. So rainfall excess will be area of the unit hydrograph half into peak discharge into 84 hours divided by drainage basin length, so 400 km square. So rainfall excess will be 0.03402. Now we have to find the peak of unit hydrograph, which is given by the ratio of peak of flood hydrograph divided by rainfall excess. So flood hydrograph peak will be 90 m3 per second. Rainfall excess will be 3.402. So peak of unit hydrograph will be 26.45 m3 per second. So the right answer is option C. Question number 55. The ordinate of 2-hour unit hydrograph at 1 hour time interval starting from the time t is equal to 0 are following. These are the ordinates in meter cube per second. A 2-hour storm occurred over the catchment area producing an effective rainfall of 2.5 cm. Assuming a constant base flow of 15 m3 per second and phi index as 5 mm per hour, the peak of resulting direct runoff hydrograph would be direct runoff hydrograph from the following ordinates. So let us plot it in a tabular column. So the peak resulting direct runoff hydrograph at a 4-hour is equal to 102.5 m3 per second. So the right answer is option D. Question number 56. Match the following. Abrasion test is resistance to weight and impact. So this C. Impact test, it is the resistance to the aggregate to fracture under repeated impacts. Option D. Soundness test, resistance against weathering. Option A. Brushing test, strength of aggregate. Option B. So the correct combination is 1C, 2D, 3A and 4B. So the right answer is option B. Question number 57. A set of dual tires has a total of 4090 kg and a contact radius of 10 cm and center to center tire spacing of 30 cm. The equivalent single wheel load as per IRC at a depth of 30 cm below the road surface is. So let's write down the given data. Depth is given as 30 cm. So Z is equal to 30 cm. center to center tire spacing is 30 cm, so S is equal to 30 cm, and contact radius is given as 10 cm, so D is equal to 10 cm. So according to IRC, the equivalent single wheel load is calculated by the following formula, that is log 10 of equivalent single wheel load is equal to log 10 of tire total load plus 0.301 into log 10 of Z divided by D by 2 whole divided by log 10 of 2S divided by D by 2. On substituting the given values, log 10 of ESW is equal to total load is 4090 kg, so log 10 of 4090 plus 0.301 into log 10 of Z is the depth 30 cm, so 30 divided by D is the contact radius, so 10 cm divided by 2 whole divided by log 10 of 2 into S is the spacing, so 30 cm, so D by 2 is 10 by 2. On solving this, the equivalent single wheel load log 10 of ESW is equal to 3.828. So equivalent single wheel load is equal to anti-log of 3.828. On solving this, the equivalent single wheel load will be 8179.43 kg, which is nearly equal to 8180 kg. So the right answer is option A. Question number 58. A rising gradient of 1 in 30 meets a falling gradient of 1 in 50 on a national highway. The existing features near the locality permit the adoption of only minimum sight distance. The design speed is 100 km/h. Minimum stopping sight distance is 180 meter. The length of the vertical curve is, so we have to find the length of vertical curve. Length of the vertical curve, assuming it is greater than safe stopping sight distance. So length of the vertical curve is calculated by the formula ns square divided by 4.4. N is the rate of change of gradient, that is from rising to falling gradient. 1 by 30 minus of 1 by 50, which is equal to 0.053. S is the safe stopping sight distance 180 meter. So length of the vertical curve will be 0.053 into 180 square divided by 4.4. On solving this, the length of the vertical curve will be 392.72 meter. So this answer is nearest to option D, 368.4 meter. So right answer will be option D. Question number 59. Match the following. Skimming tanks are used to remove oil and grease. Sedimentation tank is used to remove suspended solids. Trickling filter is used to remove biodegradable matter. Ozonator is used to remove bacteria. So the right answer is option D. Question number 60. Find the diameter of the circular sewer running with half-full condition carrying 0.06 m3 per second of sewage with a self-cleansing velocity of 0.6 m per second. We know that discharge of a circular sewer is equal to area into velocity. Discharge is given as 0.06 m3 per second. Since it is a circular sewer, area will be pi d square by 4. And running with half-full condition means it is half times of self-cleansing velocity, that is 0.6 m per second. So it is 0.6. Therefore 0.06 divided by 0.6 is equal to pi d square by 8. Therefore on dividing this, it is 0.1 multiplied by 8 divided by pi is equal to d square. So d is equal to square root of 0.254 meter. So d is equal to 0.504 meter. So the right answer is option A. Question number 61. 2 point loads, one at the center and another at the side as shown in the figure, is given in the isometric projection. The vertical stress at a point A. So this is the point. So we have to find the vertical stress using Boussinesq equation theory. So according to Boussinesq theory, the intensity of the vertical stress is given by the formula 3q divided by 2 pi z square into 1 divided by 1 plus r by z square to the power of 5 by 2, where q is the concentrated load acting on the isometric projection. So here there are two concentrated load. So by taking the resultant load of the two loads, it is 150 kilonewton. Z is the vertical depth, which is given as 5 meter. So this is the vertical depth. R is the horizontal distance between any point. So from center of the isometric projection, this is the horizontal distance between any 2 points. So taking this as 2 meter and 2 meter, the horizontal distance is 2 square plus 2 square, which is equal to 2.828 meter. On substituting these values, the intensity of the vertical stress at point A is equal to 3 into 150 divided by 2 pi into Z is the 5 meter vertical depth, so 5 square into 1 divided by 1 plus r is the horizontal distance 2.828 divided by Z is the vertical depth 5 meter. On solving this, the vertical stress at point A is equal to 1.430 kilonewton per meter square. So in the given options, it is nearer to option C, 1.34 kilonewton per meter square. This may be the possible answer because I have considered the resultant load of 150 kilonewton. Question number 62. Consider the following statements. Statement number 1. Coulomb's theory of earth pressure is preferred to analyze masonry walls. This statement is true. Active earth pressure caused by the cohesionless soil backfill gets increases by compacting the backfill. Statement is false, because active earth pressure caused by the cohesionless soil backfill get decreases by compacting the backfill. So this statement is false. Statement number 3. Basement walls and bridge abutments are usually designed for earth pressure at rest. This statement is true. Statement number 4. Wall friction decreases the active earth pressure and increases the passive earth pressure. This statement is true. Out of these given statements, the correct statements is 1, 3 and 4. So the right answer is option D. 63. A friction pile of diameter 500 mm is embedded into a homogeneous sand stratum with a dry unit weight, friction angle and earth pressure coefficient as 16 kN per meter cube, 30 degree and 3 respectively. The length of the pile required to design capacity of 900 kN with a safety factor of 2.5 is. So we have to determine the length of the friction pile. So let's write down the given data. Dia of the friction pile is 500 mm. Dry unit weight is 16 kN per meter cube. Friction angle is 30 degree. Coefficient of earth pressure is 3. Factor of safety is 2.5. So the critical depth is 0.1 times of L and the remaining depth of the friction pile is 0.9 times of L. So ultimate capacity of the friction pile is K into stress into tan alpha into pi into D into L, where stress is given by the formula dry unit weight into critical depth divided by 2 into critical depth plus dry unit weight into critical depth into L minus critical depth divided by total length of the friction pile. Stress into length is equal to dry unit weight critical depth square divided by 2 plus dry unit weight critical depth L minus dc, that is critical depth. Therefore, stress into length is equal to dry unit weight is 16 kN per meter cube. So 16 into critical depth is 0.1 times of L. So 0.1 times of L square divided by 2 plus 16 into 0.1 times of L into 1 into L minus 0.1 times of L. On solving this, stress into length is equal to 1.52 L square. So by rearranging this equation, ultimate capacity of the friction pile is equal to K into tan alpha into pi into D into stress into length. So here we have calculated the value of stress into length of the friction pile. Substituting the given values, earth pressure coefficient is 3, alpha is the friction angle, so it is given as 30 degree into pi, D is the diameter of the friction pile, so it is 0.5 meter. Stress into length is 1.52 L square divided by factor of safety of 2.5. Therefore, ultimate capacity is 900 multiplied by factor of safety 2.5, which is equal to 4.135 L square. Therefore, L square is equal to 900 into 2.5 divided by 4.135. Therefore, L is equal to 23.32 meter. So as per this solution, the length of the friction pile is 23.32 meter, but this answer is not in the given options. So I am not sure about this solution, whether it is correct or not. So question number 64. Consider the two span prismatic continuous beam shown in the figure. Find the moment at fixed end A. Given that clockwise rotation slip theta A is equal to 0.002 radians occurs at the fixed end A, assuming flexural rigidity of 8 into 10 to the power of 4 kN meter square. So from the slope deflection equation, fixed end moment at A is equal to fixed end moment of the member AB plus 2EI by L into 2 theta A plus theta B minus 3 delta L. Therefore, fixed end moment at A is equal to, since there is no external load acting on the member AB or BC, fixed end moment is 0. EI is the flexural rigidity 8 into 10 to the power of 4. L is the length of the span member AB, so it is 4 meter into 2 into theta A is the clockwise rotation slip, which is given as 0.002 radians. Theta B is 0. Since there is no deflection, it is 0. On solving this, 160 kN meter. Question number 65. The given figure shows a portal frame with the loads. Find the bending moment diagram for this frame. So for this type of the frame, the corresponding bending moment will be, since the load is given on the member BC, the bending moment diagram will be only in particular member, so it is triangular in shape since it is a concentrated load with the intensity of WL square by 8. So the right answer is option B. Question number 66. A venturi meter is 50 mm bore diameter at inlet and 10 mm bore diameter at the throat. Oil of density 900 kg per meter cube flows through it and a differential pressure head of 80 mm is produced. Given that coefficient of discharge is 0.92. Determine the flow rate in kg per second, assuming the density of water to be 997 kg per meter cube. So, let us write down the given data. Coefficient of discharge is 0.92. Radius of the venturimeter at inlet will be 50 by 2. So, it is 25 mm. Density of the oil is given as 900 kg per meter cube. So, change in pressure is given by density acceleration due to gravity into change in differential pressure head. So, density is given as 900 kg per meter cube. Acceleration due to gravity is 9.81. Change in pressure head is 80 mm. So, 80 divided by 1000. On solving this, the change in pressure will be 706.32 kg per meter cube. So, the discharge in the venturimeter is given by discharge is equal to 0.92 pi into 0.05 square divided by 4 multiplied by square root of 2 into 706.32 divided by 900 into 25 square minus 1. So, the discharge of the venturimeter will be 9.056 into 10 to the power of minus 5 meter cube per second. So, flow rate will be density multiplied by discharge. So, 900 into 9.056 into 10 to the power of minus 6. So, the flow rate will be 0.0815 kg per second. So, the right answer is option A. Number 67. Oil of density 860 kg per meter cube has a kinematic viscosity of 40. Calculate the critical velocity when it flows in a pipe of 50 mm bore diameter. So, from the Reynolds number relation, we know that it is the ratio of critical velocity multiplied by bore diameter divided by kinematic viscosity. Assuming the Reynolds number as 2000, since it is a laminar flow, critical velocity multiplied by bore diameter is 50 mm. So, 50 divided by 1000 divided by kinematic viscosity is given as 40 Stokes. So, 40 into 10 to the power of minus 6. On solving this, the critical velocity will be 1.6 meter per second. So, the right answer is option A. Question number 68. For the given data, which cross drainage work is recommended? Here, for both the canal and drainage, the different parameters are given in terms of flow rate, bed level and depth of the flow. First, find the high flood level, which is depth of the flow plus bed level. Depth of the flow for canal is 0.8 meter, bed level is 120 meter. So, high flood level will be 120.8 meter. So, this is for canal. High flood level for drainage will be 122 meter. This is for drainage. Since the drainage high flood level is greater than canal high flood level, the most appropriate cross drainage work adopted is siphon aqueduct. Option B is the right answer, so that the canal passes over the drainage system. Question number 69. While designing a hydraulic structure, the piezometric head at the bottom of the floor is computed as 10 meter. The datum is 3 meter below the floor bottom. The assumed standing water depth above the floor is 2 meter. Specific gravity of the floor material is 2.5. The floor thickness should be without considering the factor of safety. So, we have to determine the floor thickness. Let us draw a diagram so that you can clearly understand. This is floor of a thickness T, assuming the depth of the standing water as 2 meter and below the floor the datum is 3 meter. Piezometric head at bottom of the floor will be 10 meter minus datum is 3 meter. So piezometric head at bottom will be 7 meter. Therefore, standing water depth above the floor is 2 meter. So 2 into unit weight of water plus thickness of the floor into specific gravity of the floor multiplied by its unit weight of water. So total piezometric head at the bottom of the floor will be 7 meter multiplied by its unit weight. So 2 into 1 is the unit weight of water assumption. Specific gravity of the floor is given as 2.5. Unit weight of water is 1. 7 into 1. So thickness of the floor T is equal to 5 by 2.5, which is equal to 2 meter. So the right answer is option A. Question number 70. The ideal condition for energy dissipation in the design of spillway is the one when the tailwater curve just coincides with the jump rating curve at all discharge. So option B is the right answer. To ensure this protection in the region of hydraulic jump, a simple concrete apron or apron length of 5 times of y2 minus y1 is provided. So the right answer is option B. Question number 71. A big building obstructs the chain line MN. A line MQ was measured on the left side of the line MN. For circumventing the obstacle, the length MQ was 450.5 meter. So MQ length is 450.5 meter. Similarly, the line MS was measured on the right side of the line MN, whose length was 550 meter. So MS length is 550 meter. The points N, Q and S are in the same straight line. These are the points Q, N, S which are in the straight line. The length of the Q, N and NS are 251 meter and 274 meter respectively. The distance MN. So we have to find the distance between M and N, where there is a obstruction in between the line MN. So let's first write down the given segment length meter. First we have to find the angle alpha. So let's find out the angle alpha by applying the cosine rule. Consider triangle MQS to find the angle alpha. Let us assume MQ segment as A, MS segment as B and QS segment as C. So to find a particular angle, that is alpha, the distance A should be on the opposite side of the angle, where A is equal to 450.5 meter, B is equal to 550 meter, C is equal to total length of the segment QN plus NS. So 251 plus 274 meter is 525 meter. Therefore, by applying the cosine rule, A square is equal to B square plus C square minus 2BC into cos alpha. A is the length of 450.5 meter, so 450.5 square. B is the length of 550 meter, so 550 square. C is the length of 525 meter, so 525 square. 2 into 550 into 525 into cos alpha. On solving this, the value of cos alpha is equal to 0.649. to find the length of segment MN considering the triangle MNS. Similarly, applying the cosine rule, angle alpha should be opposite to the distance we have to find. So let us assume as A, so the value of B is equal to 550 meter and value of C is equal to 274 meter. So we have to find the distance of MN, that is A is equal to how much. So as per cosine rule, A square is equal to B square plus C square minus 2BC into cos alpha. A square is equal to 550 square plus 274 square minus 2 into 550 into 274 into cos alpha is 0.649. Therefore, A square is equal to 181967.40. Therefore, A is equal to 426.57 meter. So, it is the distance of line MN. So, the right answer is option C, 426.34 meter. Question number 72. The magnetic bearing of a line was found to be north 50 degree 30 minutes west in 1992. When the declination was 5 degree 10 minutes east, find its present magnetic bearing if the declination is 2 degree west. We know that true bearing is equal to magnetic bearing plus or minus declination. So first we shall find the true bearing of a line. So magnetic bearing is given as north 50 degree 30 minutes west. So 50 degree 30 minutes, it is a declination of west, so we shall take as negative. So true bearing will be 48 degree 30 minutes. So for the present magnetic bearing, we know that true bearing is 48 degree 30 minutes. Magnetic bearing, since it is a eastern side declination of 5 degree 10 minutes east, we shall take as positive. Therefore, present magnetic bearing will be 48 degree 30 minutes minus 5 degree 10 minutes, which is equal to north 43 degree 20 minutes west. So the right answer is option D. Question number 73. The following perpendicular offset were taken from the chain line to an irregular boundary. These are the chainage at a 30 meter interval, and these are the corresponding offset length in meters. The area between the chain line and the irregular boundary by trapezoidal rule and Simpson rule are. So from both this formula we have to calculate the area between the chain line. From the trapezoidal formula, the area of the chain line is calculated by, where D is the chainage interval of 30 meter, H1 is the first offset, so it is 0, and the last offset is 5.8 meter divided by 2. Similarly, the remaining offsets are, so the area of the chain line of irregular boundary calculated from the trapezoidal formula is 790.65 meter square. On solving this, the area of the irregular boundary according to the Simpson rule will be 727 meter square. So the right answer is option A. Question number 74. Which of the following need to be considered when the concrete mix is prepared as per 10262-2009? The main parameter to be considered when the concrete mix is to be prepared is alkali content in the cement. Option A is the right answer. Question number 75. What is the maturity of the concrete after 7 days of casting, where the average daytime temperature is 25 degrees Celsius and average nighttime temperature is 20 degrees Celsius? So according to Nursall, maturity function of the concrete is given by the formula m is equal to summation of T minus T naught into delta T. So in the question it is given two types of the temperature. One is at the daytime temperature and at the nighttime temperature. So it will be T1 minus T naught into delta T plus T2 minus T naught into delta T, where T1 is the daytime temperature which is given as 25 degrees Celsius, where T2 is the nighttime temperature which is given as 20 degrees Celsius. T0 is the daytime temperature which is assumed as minus 11 degrees Celsius, where delta T is calculated for 12 hours. So it is given for the 7 days. So 12 hours into 7 days. So 84 hours. Substituting these values, the maturity index of the concrete will be T1 is 25 degrees Celsius minus T0 is minus 11 multiplied by delta T is 84 hours. T2 is 20 degrees Celsius minus of minus 11 degrees Celsius multiplied by 84. So the maturity index of the concrete will be 5628 degrees Celsius. So the right answer is option A. So this completes the part 2 questions of this question paper. I hope all the information and detailed solution provided for this question paper is satisfied for your examination preparation and as a reference for other civil engineering competitive exams. So thanks for watching this video. Thank you all.